Hello, everybody. Good morning, good evening, good afternoon. Welcome to our webcast, depending on whatever time zone you are in. I'm so glad that I have these three gentlemen with me. I've known them for a long time. My name is Kenneth Wong. I'm editor for DE 24/7 and the moderator for the DE Hot Seat webcast series, where we put the latest trends and technologies under the microscope, as it were, to see if they are solid, practical, or if there are loopholes that we need to talk about. Today's topic is about the intersection of additive manufacturing and subtractive manufacturing. And this talk is made possible by Velo 3D, HP, and Desktop Metal. Thank you so much for sponsoring us. All right. Now, a few housekeeping items as we wait for other people to join. Before we begin our talk, let me just remind you that if you have questions about the topic or questions for the panelists, you can drop them into the Q&A box at any time. We'll address them in the Q&A session after the presentation and the discussion. We'll get through as many as time permits. For the ones that we cannot get through, I promise I'll work with these three panelists to make sure that you get a written response. You can also get a PDF copy of today's slides and check out the resources related to the topic in the resource resource list to the left of your slide window. If you are experiencing any technical issues, you might want to visit our webcast help guide by checking the help ? Icon at the bottom of the console. If the slides are not advancing, you might want to try refreshing your browser window. That usually solves a lot of the problem and get you back on track. So let's talk about today. In most headlines in the industry press, the spotlight usually falls on additive manufacturing or 3D printing because that happens to be the sexy, hot, headline-grabbing technology you're hearing a lot about. But in reality, traditional manufacturing, otherwise known as subtractive manufacturing, also plays an important role. So today we are looking at the cross-section of these two. We're going to spend the next 24 hours examining every possible aspect that we can imagine. Just kidding, because if we want to do that, I know that these three gentlemen have the skill to do that. So in the next 50 minutes or so, we're going to spend 50 minutes of your time valuably and talk about the intersection of these two technology. Let's meet our panelists and hear their opening remarks. I'm going to start with you, Gene. Gene is from Velo 3D. Gene, welcome. Please give us your self-introduction and your opening remarks, please.
Sure. Thanks, Kenneth. Hello, my name is Gene Miller. I'm a technical sales engineer here at Velo 3D. I've been with the team now about 5 years. I have experience in casting and foundry tooling design, as well as manufacturing engineering. And I'm really excited to talk about the pain points of traditional manufacturing and actually how well it complements additive manufacturing to help us move forward to the next step of what we can actually make and have a successful part for design engineers at the end of the day. So really looking forward to our talk today.
All right, Gene, and go ahead and do your opening remarks, and I believe you prepared some slides to share with us.
Sure. So are you able to see my slides?
Perfect.
Okay, so let's talk about Velo 3D. What we are is a newly found next-generation laser powder bed fusion company. We founded in 2014. We are targeting difficult-to-manufacture geometries and parts that were before difficult or impossible to manufacture on legacy manufacturing for additive manufacturing systems. We enable some very unique geometries and challenging components. Here's an overview of what we're going to talk about quickly. Our main target, our main customer has been SpaceX in the past. We are helping them enable their Raptor technology, and really they have expanded from one system to 22 systems in just 3 years of our partnership. So really a strong partner for us and helping us improve our processes and move forward in the future. Another part we helped Sierra Turbines print is a micro turbine generator. This is it's a combination of about 60 parts, and they were able to print this on a Velo Sapphire where they just couldn't do it on a conventional system. I think they received 5 no quotes that they just denied to try and even print this part. Velo is able to print these complex internal geometries without any added support material or the need for any removal after printing. We're very well poised to print shrouded impellers and rotational machinery. Sometimes in commodity manufacturing or commodity additive, you would have to tilt this and you'd lose roundness of the part, and you'd have trouble balancing it and rotating it in your final application. Because we can print these flat without any supports, it's just a very easy, simple post-machining operation and then a final application. Mohawk is another power generation solution. We have these very complex volute sections that are very inaccessible. This is another good example of how you couldn't get out any of the support material that you would add into some of these volutes and channels. Our PWR heat exchanger, we use something called a non-contact recoater, and this is really revolutionary in the industry because we are not smearing powder across the powder bed in kind of a crude fashion. We're delicately dispersing powder across the powder bed and removing all but a very thin layer. So these very thin turbulators and very thin walls can be printed without any type of interference from the recoating mechanism. Our partner KW Micropower, along with N-Topology, helped us print this one. This was a housing for a generator where we did some cooling of the generator and preheating of the fuel to really help increase the efficiency of the part. And another one where you would have to add a lot of support material on a conventional AM powder bed fusion system. Titanium is a different beast. It prints and is very prone to cracking, and this is a 10-inch diameter diffuser that has some very inaccessible low-angle features on the inside of the part. And Velo has found a very unique technique to reduce or ameliorate the problem of internal stresses in the print. We can print very large titanium parts without the fear of cracking so much as other conventional systems. Pressure vessels are a great example of where Velo technology really shines. We can print extremely low overhangs without the need for any support material. I don't really have to tell you how impossible it would be to get support out of a pressure vessel if there's one tiny little opening at the top. Launcher has been a great partner for us as well. Their recent locks and pump, we printed 3 components for: the inlet and the outlet, as well as the impeller. The impeller we can't show because of ITAR reasons. However, it was another example where we printed an impeller flat on the build plate. It was able to be balanced and used in a cryogenic application at 30,000 RPMs. And there's another webinar on this. They tested the pump, and right out of the gate, they had just huge success, which is very difficult and doesn't happen all the time in the world of aerospace or space engineering. The outlet is Inconel, the inlet is aluminum F357, and the impeller was out of Inconel 718 as well. And I'll go ahead and I'll give it back to Kenneth, and he can introduce Anthony for us.
Thank you very much, Gene. Looking forward to start discussing some of those details with you later. So next, I'd like to call on Anthony. Anthony, your opening remarks and self-introduction, please.
Thanks, Kenneth. And actually, that was cool. I learned some stuff from Gene there in that short period of time. My name is Anthony Graves. I'm the Senior Director of Product and Strategy for a team inside of HP called the Digital Manufacturing Software Team. Most people, when you think of HP, you think about personal systems and Z workstations, particularly in our field, and small inkjet printers to giant 2D printers and 3D printers. But I joined the company just over 2.5 years ago, and the mandate for my team has been to look for ways to expand business opportunities for additive manufacturing, period. For MJF, certainly, which is an HP technology, along with all the other technologies and processes out there, both for polymers and metals. And one of the ways that we're doing that is developing tools that we put under this umbrella term of Smart Factory that are geared towards supporting product fulfillment as well as business models around personalized, customized, and on-demand additive manufacturing. I know a lot of people for years have been wondering if additive was ever going to replace technologies like subtractive, CNC machining, CNC fabrication, injection molding, and maybe in time, additive's going to make some inroads in those very low mix, high volume production areas. But for now, and just using Gene's examples, there are use cases that additive can produce parts that cannot be produced any other way. And so even with other additive processes potentially. And so by default, we are talking about looking at areas where do the high volume orders exist, and that is in personalization. Think medical implants, think orthotics, think eyewear, and eye care, consumer products that are being personalized. So my team has been working not only internally with our HP Labs team and other groups within HP, which is an engineering company at its core, but also reaching out to other OEMs like Velo, Desktop Metal, and others, even in companies like Stratasys in the polymers area, as well as other software companies like Materialize, Autodesk, Siemens, to develop solutions to really raise the bar for the whole industry. Additive has incredible potential, and we think that in the area of personalization, customization, on demand, that's a sweet spot. And if we can help in some way allow all of the additive industry to tap into those commercial opportunities, it's going to benefit everyone. So that's basically what my team does in a nutshell. So thanks for having us, Kenneth. We really appreciate it.
Thank you very much. We'll come back to you with more questions. For now, let's go ahead and meet the third panelist. Aaron Kelly, you're up. Your self-introduction. Go ahead.
Oh, sorry. Thank you, Kenneth, and everyone who's attending, and as well as my fellow panelists here. My name is Aaron Kelly. I work at a company called Desktop Metal that we're going to introduce you to today. I've been here for a total of 2 years, and my role at Desktop Metal is sales enablement, where I'm responsible for sales tools and as well as the technical sales team. So let's go through some slides. So Desktop Metal was founded in 2015. And our mission is to make industrial-grade 3D printing accessible for all engineers, designers, and manufacturers. In fact, our promise is to deliver cost-competitive, high-speed, exceptional 3D printing. How are we different? I think we're different in that we're responding to something that's changing. The additive manufacturing industry, I believe, is at an inflection point. And that inflection point is going from what we call additive manufacturing 1.0 to additive manufacturing 2.0. So with additive manufacturing 1.0, you've seen many 3D printers being adopted, right? Being sold all around the world, different technologies as well. Lots of different technologies being deployed in these additive printers. In fact, there's tons of materials that you can choose from through these technologies. Some of these parts being produced from additive 3D printers today are for end use, but most are for prototyping. Most are 3D printers out there printing an ABS or a PLA or some other polymer, and they're printing one part at a time. It's kind of slow. It takes hours to print that part, and it's really not scalable. We're talking about additive 2.0. We're approaching the next generation of this technology. This is where we'll enable the creation of end-use parts, not just prototypes that do fit and form. We can even extend the prototypes from fit and form, but to function as well. And we're talking about metal parts, for example, but also have the finish and the accuracy and the speed and the costs that are aligned for manufacture. This is all going to be driven by a couple things. Accessibility. Parts that were too expensive or maybe too difficult to print can now be justified with new low-cost, accessible 3D printing technologies like binder jetting, a technology that Desktop Metal uses, and high-volume manufacturing. What used to be a niche manufacturing process to produce one or a few parts, a handful of parts, can now be used to produce end-use parts in high volume. So when I say high volume, we're talking about dozens, hundreds, thousands, even tens of thousands of parts printed per day. This all depends on material and part size, but we're talking about volume production. This is a game changer, and I'm sure many of the attendees are not aware of the changes and the capabilities that now exist in additive manufacturing, especially in the terms of speed and throughput. We're also talking about numerous materials, from metals to polymers, even wood. Now, with the systems that can go from prototyping, now we have systems that can go from prototyping, right, from form, fit, and function, to building parts that are impossible to print with subtractive. But what makes that key is, now that we can do this in volume, we can leverage these designs that weren't able to be done in subtractive, that can be done in additive. Now we can make them at volume, and I think this is going to be a game changer. And with that, I'll turn it back to you, Kenneth.
All right, thank you very much. The next thing I want to do is actually conduct a poll. While audience would like your input on this while we have you here, because you represent a cross-section of the engineering and manufacturing community that we serve. So here's a poll. Our firm uses mostly, this is a highly simplified way of talking about it, but let's just get a general idea of it. So our firm uses mostly subtractive manufacturing, mostly additive manufacturing or 3D printing, a mix of subtractive and additive manufacturing. So I'd like to see where you stand and where our audience stand in terms of the workflow. A lot of the time people think that additive manufacturing is becoming more powerful and it might overtake subtractive, but all of us get the feeling that that may not necessarily be the case. So let's see where you are. Let me take a look at the results here. Okay, mostly subtractive manufacturing still stands as the majority of the case, or actually nearly half the case, and a quarter of the people are using mostly additive, but 30% of the people are using a mix of subtractive and additive manufacturing. Aaron, let me start with you. What does this bar chart tell you? What does it suggest about the industry and where it is heading?
Actually, I'm quite encouraged by it. The mixture is higher than I would have thought. I think that certainly subtractive manufacturing, it's going to dominate, right? It does dominate. It's fantastic. We make most of the things that make the world go around with subtractive today. That's not a surprise. But what I love to see is that mix of subtractive and additive manufacturing, that number is going up. And I think in the next few years, we're going to see that even increase further, because additive manufacturing, I don't think, is used to its potential. Right now, I still believe we're doing it on low volume prototyping type things, and I think that's going to change over the next couple of years. So I'm encouraged by this.
All right. Gene, what about you? When you're looking at this bar chart and the responses, what does it tell you about the industry?
I have to, second what Aaron said. I'm really optimistic about seeing this. I think it's something that commonly gets overlooked by the layman who doesn't have experience in additive or subtractive and looks at manufacturing from the outside in. But really from the inside out, all of these processes have to complement each other, and they all work together to deliver a turnkey part. When we did casting hundreds of years ago, how many times did you have a cast part come right in and put it into a machine in an application? You had to post-machine these things. They had to be, fit the need of the application. And it's going to be that way moving forward with AM, at least for this foreseeable future. And I'm really excited to see that, we're getting a mixture of folks, interested in this discussion here today.
Anthony, does it suggest, in terms of a software developer's strategy, which direction you should be going, looking at this chart?
Not necessarily. I don't think. One of the interesting things was, and I hadn't really thought about this until I saw this chart, and that is, it would have been interesting to see how many people are using a mix of subtractive and injection molding, and also beyond mold and die, which of course is CNC machining driven. I mean, that is the industry, but also how many people are doing mostly injection molding, because there's probably some product designers here that are attending the webcast, and maybe most of the parts that they're designing are being injection molded as well. And so the reason I even bring that up is because many people equate CNC machining to metals machining, which is probably the predominant material that's being used in CNC machining or people are using for CNC machining. But injection molding, it's plastics, and additive, where I think has made some significant inroads, is as an alternative to short run, very complex part injection molding, because the molds themselves cost so much to produce. And if you're only looking for a small quantity, you can't always justify it. So additive, I think, that's one of the areas where it's really been able to showcase the benefits of the technology. And with companies like BASF and Evonik and others, every year coming out with more and more materials, and those materials being qualified, I think that's one area where additive is giving at least injection molding a run for its money.
All right, very good. Okay, let's spend the next 25 minutes or so, not the next 24 hours, although I know that many of you would, all of you would be happy to do that. So we'll spend the next 25 or 30 minutes or so talking about different aspects of this. I'm going to start with you, Gene. Now that previously people thought that if only metal printing were possible, then we could just forget about subtractive and start moving all our processes to additive manufacturing. Metal printing is now possible, but does it mean that AM is going to replace everything that used to be done with machining and subtractive?
I'll answer that question based on what Velo is doing, and specifically like laser powder bed fusion. We aren't going to see our version of metal AM replace manufacturing or subtractive manufacturing anytime soon. With what we do, machining is the perfect complement to printing a part that's otherwise unmakeable, unmanufacturable, and then machining takes us to the finish line. Without it, we would be lost in most cases, where we need threads cut on a part, we need sealing surfaces and a machine surface. We need this, and without it, we wouldn't have a useful part. And what we're doing as a company is really enabling a new design space for engineers and designers to make new parts and new products. So really, we are bolstering the subtractive market by adding these new applications and opportunities that can be, ways to use subtractive manufacturing that weren't possible before. So it's a great complement and absolutely necessary for what we're doing, and it's going to be for a long time.
All right. Aaron, what do you think? Desktop Metal, actually metal printing is in the name of your company. So it's becoming possible. Does that mean that it's going to push out subtractive and replace everything?
No, I agree with the panel. I think everyone has said not in the anytime soon time frame. Certainly, subtractive manufacturing has huge benefits. There's strengths and weaknesses with both technologies, right? And if we take a look at that, I think that's what's going to drive ultimately what customers are going to do. And ultimately, I think they're going to adopt both technologies, because it's the business that's driving those decisions, right? It's getting time to market. It's reducing lead times. It's reducing costs. It's trying to get better products out the door. All those things are going to drive customers to look at these technologies to solve those business problems. So with that, let's talk about some of the strengths and weaknesses, right? With additive, one of the strengths is speed, throughput. You don't have the tooling lead times that you would have with subtractive. So you can shave off weeks, months from a product line, right? For example. One of the strengths that you have with subtractive is you can get tight tolerances, right? You can get very accurate parts. If you put that together, for example, Anthony brought up the, like a mold design. some parts need deep pockets cut out. And additive, you don't pay for the removal of that pocket. You don't have to have a tooling doing the removal of that pocket. You can have an additive part created. You're only using the material you need. And when you need those fine surfaces, you need those high precision tolerances, right? You can then take that part and move it over to your CNC machine, and you can finish it. That's a perfect example of how the two technologies complement each other. And it's to solve those business problems. One of the biggest problems we're seeing is during this pandemic, supply chains. Supply chains are disrupted. And one of the things that additive can do is enable people to take some of those parts, the manufacturing, in-house. So maybe not have them produced across the Pacific and try to get them over on a ship. It's very difficult to do nowadays. Lots of customers are looking at, how do I change my supply chain? How do I, even when we get through this pandemic, I'm looking at, I don't want this to happen again. I want to look at for advantages. With lead times so tight, with tooling and time to market so important for customers, right? A day or two can be millions of dollars. Additive is going to help them shrink some of those times. So strengths and weaknesses with both. Sometimes there's just very synergistic processes. Like, for example, some sort of mold where you started off in additive, finish it off in subtractive, and it works fantastic.
All right. Let me turn to Anthony now. That let's talk about the role of software. What role does the software play in enabling people to adopt additive, or actually enabling people to figure out how to use additive and subtractive in a complementary fashion?
Yeah, it's interesting because for most of us, CNC machining or machining started to evolve before we were born. Most of us have been around long enough to see additive grow in front of us. And so I think for the first 2 decades, there weren't that many people materialized as the one company that was really out front. As the technology was evolving around additive, you had a combination of the processes evolving, the equipment, the printers, the 3D printers and post-processing equipment evolving, and the materials all evolving at different paces. And as those technologies and the science behind the materials started to mature, everybody looked around and said, "Oh my God, the technology has outpaced the software. The hardware has outpaced the capabilities of the software." And so you've seen companies start to pop up over the last decade, and even especially in the last 5 years, where they have you've started to see across CAD and simulation and CAM, which I'll describe CAM as both additive and subtractive. CAM, you've started to see people pay attention because the market is there for people to purchase the software. And so you have 2 areas, or 3 areas. You have the CAM companies, the simulation companies, and then these component technologies. I think Gene mentioned and topology. They worked with them on a special project together. There's Polygonica, Siemens, Dendrite, Hyperganic, a number of different companies. As a matter of fact, that whole concept, or I would say statement about hardware outpacing the software, I first heard from the CEO of Dendrite. And that's why he said he started the company, because these new technologies require the software to drive them, both in sophistication and also performance as well. So we could take each one separately, each one of those technologies. We won't. We'll do that in hour 2 and 3. But I think software is starting to come into its own because the market's been there. It's really been CAD and I would say materialized from a CAM perspective up until the last 5 years that have done anything with DFM, DFAM, and of course, getting the actual print files to the machines. Now that's starting to change a lot, and I'm sure we'll touch on that later.
All right, now let's talk about designing for additive manufacturing to get the most out of it. I'm going to turn to you, Gene. There has been an impression, and probably it's because the vendors promote this idea that all you have to do is hit print and the thing will come up in about 1 hour or so magically. But is it really as simple as that? Are there things that people might be underestimating about AM?
If that were true, I wouldn't have a job, man. I would serve no purpose. There is no Staples easy button for this. You have to be educated. You have to know what will actually print. And that's education that, Velo would help our customers with that, so that when you are receiving a model, a design that an engineer has created, you need to look at it and say, I can print this overhang, but I can't print this one. I need to put support on this. And there are design considerations that you really need to take into account. You can't just put it in a virtual space, click print, and hope for the best. That's not realistic in the world of engineering in general. And it's not an additive manufacturing thing. We have to take these considerations into account when we're designing for the application and for the manufacturability of our parts and our components. So no, it's not easy, but it is a learnable skill, and it doesn't take rocket surgery to figure it out.
Aaron, you actually have an extensive background in CAD. Do we need a new kind of CAD? Because CAD has a rooted history that is rooted in machining and subtractive manufacturing. Do we need a new kind of CAD to be able to get the most out of additive?
I'm going to say yes and no, and then try to be more definitive than this as I talk. So Gene and Anthony made great points, right? There's things that you don't know at the start, right? And you don't know that there's support structures that are needed under this condition. You don't know that there's a post-process that needs to be done under that condition. And that's across subtractive and additive, for that matter. So you have to learn those things. I think CAD could do some more of helping people understand those limitations, right? And what Anthony said, he gave us great examples of different CAD, different software out there for additive, but there's lots of different software for additive. It's kind of fragmented. People specialize in different areas. So yes, in terms of putting things together, no, I don't know that we need any more CAD companies or software products, but maybe some of the features and maybe some consolidation would help. I did work for a large CAD company that most people would know for about 20 years. And so I've thought about this a lot. I've thought about this a lot. And as Anthony said, CNC programming has been around longer than us, right? 70 plus years, whatever. And CNC programming, or the automation, drove, I believe at the start, 3D CAD. Now, once we get to 3D CAD and it's proliferated, 3D CAD is driving additive. You can't have additive without 3D CAD. You need that model. So the proliferation of 3D kind of drives that. There is a kind of an intersection as well where I think that mass production of 3D printing parts with generative design is something that hasn't made mainstream appeal yet. I think a lot of people are interested in it. But when you bring that part that looks a little weird to your boss, and your boss says, how are we going to manufacture that? That's a real challenge. So even though you can design it, doesn't mean you can build it. Now, with some of the new technologies, like what Desktop Metal is bringing with binder jetting, we are able to mass produce parts that are created with generative design, some geometries that really aren't suited for subtractive. Now, generative design is not limited to additive either. Let's make that point. There are generative design algorithms for subtractive manufacturing processes. Most of the companies that do generative design have the option. What is your process that you're going to make this of, if you know it, and then we'll try to limit it to the capabilities of that. So I think when we look at CAD today, it was built really for subtractive, right? When you think about it, it was built 30, 40 years ago for subtractive. The features were built as you would machine the part. That's why you have features that are like cuts, rounds, holes, shells. You know, you built the model, 3D model, as you would believe that you would do it. So the features are aligned for subtractive. So I think that could morph. Generative, I think, is limited in mainstream because you can't produce it in mass quantities. And then the last thing I would say that needs to change or extend a little bit more is the use of mesh-based files. So in additive, lots of STL files are used, right? They're swapped here and there, not BREP, not the solid bodies. And sometimes it can be hard to manipulate those. And Anthony mentioned a lot of great software products that can do that, but the CAD products aren't some of those products that can easily work with that mesh stuff. But I think that kind of stuff would add to the value of CAD and the proliferation of additive manufacturing. If we do those kind of three things, if you will, a more tack towards additive features, being able to now, with the additive community, being able to produce these generative designs. And then the third, working with STL files more as a native body or file type in the CAD systems themselves.
What do you think, Anthony? Go ahead. Add your thoughts on this, please.
So a couple comments real quick. First of all, Aaron's 100% right as far as the proliferation of STL. I mean, STL was created for additive in the very beginning. That's why we have STLs. I don't think we can get rid of STLs fast enough. I know I belong to a growing majority of people in the industry that would love to get rid of STLs. More and more printer companies, HP, for example, they started out with what they called their 4200 series MJF print system, and now they're into their 5200 series print system. In the 5200, you actually send a 3MF file in, which actually is mesh-based rather than slices, and we'll call it the first generation or first iteration of the printers. I know other companies are starting to take a look at importing directly in those models. It doesn't make it, as easy as the easy button, like Gene said. There still is no easy button, but that's one step towards it. Taking it the next step is the OEMs actually supporting the ability to be able to print B-reps. And then we get rid of this nonsense about having to repair STLs. It is a total time suck, and regardless of how far the additive technologies advance, both in plastics and metals, if you don't get rid of this nonsense about having to touch every single file, then you're not personalizing. You can spend 8 hours tweaking meshes to produce 100,000 parts. But if you have 100,000 orders of the same part that's customized, you can't touch them. So now using BREP, you can do that. And that's Aaron's background. He was, with one of the companies that pioneered it. But I do want to mention something, and being an HP, I might get in trouble if I don't, because one of the things that everybody was super excited about when powder bed polymer printing came out, and with HP and the MJF, we have, for years, people have talked about multi-material, the potential for multi-material. So I will say, as the next sort of huge opportunity is going to be around the ability to print materials using additives, where you have a combination of powders and additives, where you can produce a part where you can, for example, print traces. Now, other people have done this with nylons and carbon fibers and to strengthen parts and super cool technology. But when you have the ability to print in one printer these multi-materials, and you have an electronic component that has a circuit board built into it, it's going to transform things. And the CAD, this is another thing, and I don't have personal knowledge of this. I know people are thinking about it and talking about it, but maybe secretly one of these big CAD companies is working behind the scenes. Somebody has to be able to combine that into a CAD tool, or you won't be able to design products that the printers are capable of printing. So whoever out there, that's watching this, maybe you're a college student and you want to invent the next great thing, and a warning to all the other existing CAD companies. If you want to stay relevant, you're going to have to focus on that. So I think Aaron's 100% right. The existing CAD tools need to focus on making sure that they support both meshes and BREPs, because these meshes come in from scans for biodata and things like that. And there are a lot of gaps in the existing CAD tools to address existing workflows and use cases. But I think looking into the future, it's going to expand considerably when you look at what additive makes possible. So I just wanted to add that comment in there. So thanks.
Very good. To the audience, let me remind you that we have some questions that came in during the registration process. We have queued them up. We'd also like to see your questions as well, since you are attending it live. So if you have any specific questions for the panelists or about your specific process, things you'd like to try out, it's your chance to ask the experts questions. We'll go one more round of discussion here, and that is about mass adoption of AM. With machining, you are pretty much guaranteed that if you print the same object from the same file thousands of times, you are going to get the same quality, the same object within an acceptable tolerance. Can we say the same about using metal AM or whatever kind of AM for mass production? Let me start with you, Gene.
So I think yes to a certain degree, but there's considerations. There's a million ways that things can go wrong, and one way for it to go right. And getting back to that thing of, hey, there's no Staples Easy button here, you need to take that into consideration when you're preparing your part for printing. Say I have a feature that I need a very, very tight tolerance on, something like, plus or minus 2 thou. It's tight for a machine or for a CNC. If I have that as printed, I'm not going to hit that, man. That's really tight. That's really challenging. So you need to take that into consideration and say, like, that's going to be important to post-machine that part. So add machine stock on it. You can take these things into consideration from the front end and prepare yourself for success on the back end. And if you have something that is scalable, and Velo is trying to target that right now, let me rephrase that. We are targeting that right now. And it's not something we're saying we're doing, that you can print the same part with the same file on machine A in Austin, Texas, and then take that same print file to machine B in Japan and run it the same print with the same outcome. We can do that. And I think when you have something scalable like that, it takes a lot of the variability out of the equation. So out of the front, you design and add stock and take all these considerations into account. Now you have your print file. What are you going to do with it? Well, if you're using a Velo Sapphire, you can print it wherever you want, and there's that traceability, that repeatability. It's all there. And this is something that we are doing for several of our customers right now, providing them with one print file that they're printing at multiple locations. And that's where the scalability of this, I think, really plays into effect, because on some of the other machines out there, you have to tweak the file for that machine, for that calibration, et cetera. And then as you want to expand to other machines, you have to have different print files. So that scalability is really, really difficult, in that regime when you're trying to do something as repeatable as a production line of parts.
All right. I'm going to ask you this question, Aaron. With mass production, metal is seen to be the holy grail of the material, because that's where you get the most durable kind of objects. So does that mean that as metal printing become possible, people will start to forget about polymer-based 3D printing? Is polymer-based 3D printing becoming less important because of metal capacity?
Oh no. In fact, I don't think there's an impact at all. You look at the manufacturing today. There's lots of parts being manufactured that are plastic, polymers. Lots of parts that are being manufactured metal. These processes, I don't necessarily think are going to have an impact on one or the other. Sometimes the materials do make a difference, right? Depending on the application. If you're doing end of robotic arms, then sometimes, there's a weight consideration there. Plastic might be great. Some of these polymers that come out are really, really strong, like the peak materials we have in our fiber printer, for example. So they don't wear down as much. So there may be an opportunity to switch to plastics in some cases, and then vice versa. In some jigs and fixtures, for example, plastic is doing a great job today, but they wear down a little bit quicker, so metal might make more sense. So I'm not sure they're interlocked, but I will say that both, and I'll even include wood too, because selfishly, Desktop Metal has printing options for wood as well. We do polymers, we do metals. We have a great business on both sides of it. We see the drive from both sides of it being towards manufacturing. So you have to make lots of these parts. It's not about making one part anymore or a couple of parts. Sure, there's applications for that. I understand it. But where everyone wants to go to is manufacturing. And I think in the polymer side of things, the technology has been around a little bit longer than the metal side. So I think metal's just getting a little bit of the light right now because there hasn't been, up till now, a solution that will enable people to make metal parts at volume. So on the polymer side, I think there has been, and I think there will continue to be more and more, like our brand Division Tech does a great job of making lots of parts, polymer parts. I think the shine is on metal now. I think the cost structure and lead times for tooling and such, I think may be a little bit more attractive with metal right now, but I don't think they are in competition with each other. I think they're two separate needs, and I think they're both driven by business decisions to cut times to market and cut costs per part.
All right. Anthony, what would you like to say about the repeatability of consistency of AM printing? And while you're at it, maybe you can also talk to us about the software's ability to simulate the behaviors of printable materials.
Okay, excellent question, Kenneth. And I would like to talk. While Gene and Aaron were talking, I made this very sophisticated diagram. If you can zoom into this. It's true. I spent about 30 seconds on this. This diagram, here we have additive and we have CNC. We have tolerance and we have complexity. Everybody knows that if you want to get super, super, super complex parts produced, you're immediately going to look at additive. Whether you want one or you want 100,000 of them, you're looking at additive because it just makes sense. There's no setup. It's just super simple to set that up. With CNC, the line starts going up because the tolerance, when you want super, super, super tight tolerances, then the advantage leans to CNC for repeatability, of course, and repeatability is somewhere on that scale. And right around the middle, you have injection molding, which is sort of like that sweet spot. So when they were talking about this, I think that's an area where a lot of the companies have been able to improve through learning through their customers and interacting with their customers. I know HP has spent a lot of time on this subject, as I'm sure other companies have. But the challenge is when you're dealing with additive, it's beyond simple speeds and feeds. Okay, so in Subtractive, I have my material, I go to the machinist handbook, I have this tool, I have this many flutes. It's made of this material. This is how fast I can drive it to remove that material, right, through the material. Drive the tool like an end mill. In additive, it's much more complex, particularly when you get into powder bed, because now you have the chemistry, the physics of the machine. You have all of these dynamic forces at work. And then you take that machine where you have a climate-controlled environment in Georgia, Atlanta, Georgia, and you move that machine to Vietnam. Whether it's plastics or metals and you don't know what the climate control is, or you move it from Atlanta, Georgia to Charlotte, North Carolina. Just having the machine in two completely different settings is going to give you two different starting points. And just like in metrology and CNC machining, you have climate-controlled rooms and a very high precision at subtractive environments. You want to control the climate so that you can control the process around the material. When you get to additive, it makes it much more of an issue. But I think as we go by year after year, you're starting to see additive become more and more repeatable, like Aaron says. And the ability to produce many parts at volume, maintaining the tolerances across the parts. And it's not just from part to part, it's and the variability, it's from machine to machine variability as well. So I think over the next 10 years, hopefully it doesn't take that long, but we're going to see a lot of improvement in those areas. And just to touch on the second question that you had, and that is around software and additive and subtractive, because there's hybrid machining where you have additive and subtractive. DMG Morisiki is a big company. I think Mazak is one of the leaders in that area. If I'm missing anyone, forgive me. But they're two of the big world leaders in CNC machining that have got into hybrid years ago. And companies like Autodesk with NetFab has CAM and simulation. Materialize has CAM and simulation. Siemens has CAM and simulation. And it's not just additive CAM, it's also subtractive CAM, and they're combining those technologies together. And then you have pure simulation companies that are trying to move more into additive CAM, like ANSYS, Hexagon MSC, and also Altair. And so those companies, by virtue of competition, are pushing each other to, I think, deliver the goods as far as giving designers and engineers and more importantly, probably right now, manufacturing engineers, the ability to predict and therefore create a repeatable process. And the repeatability around the equipment is going to just come over time. So I'm encouraged by what I've seen from those companies that I've mentioned, and I'm sure there's others out there that I haven't heard of, or maybe will be coming out over the next year or two that are going to help drive that as well.
All right, let's move to the Q&A. So audience, if you have questions, please go ahead and type them and send them to us. In the meantime, let's go ahead and start addressing the question that came to us during the registration process. One question is, do you consider it hybrid only if it is done by the same machine? Isn't most AM post-processed with some amount of machining? So I'm going to start with Eugene, since it's a hardware guy, so you should start with that.
Sure. So I would consider a hybrid machine anything that's doing, like, for example, additive and subtractive processes in the same unit. We add material, then we take a little bit away. We add material, we take a little bit away. So it's doing both types of families of manufacturing in the same platform. So I would say that's a hybrid machine. For our parts, we aren't a hybrid platform. We would have to post-machine them outside of our machine. We can't really put like cutting fluids and chips inside our chambers, so it doesn't really make sense for a velo. But they're very easily removed from the machine and post-processed elsewhere on a CNC machine that would be a secondary process.
All right. Aaron, another related question as well came from SimData, the analyst firm that we follow. Do you see AM and subtractive becoming added together in AM 2.0? So what are your thoughts on that?
So I'm going to say similar to what Gene said. There is hybrid devices, and those have a place. I don't necessarily think that AM 2.0 is going to include those types of devices. I think AM 2.0 is about making lots of end-use parts fast. Do I believe that AM as a subtractive as a secondary post-process is still going to be important? Absolutely. Absolutely. When we're talking about making, literally tens of thousands of parts a day, printing tens of thousands of parts a day, depending on the size of the part, if you need some of those parts to have tight tolerances, you're going to have to machine them. Our machines are not going to hit the same tolerances that you can on a very expensive, CNC machine. So you're going to need it. The same machine, I don't think so. I don't think you get the throughput. I don't think you get the speed. And if Additive 2.0 is about speed, throughput of end-use parts, I think they're going to be separate.
All right. Anthony, this question is related to software. Is there a place where we can get the knowledge related to machine material, machinable AM materials developing or being documented? Do you have any perspective to share on that?
Sure. And this subject comes up quite a bit, and I know it applies both to polymers and metals, because even when we're talking about metal printing, we're talking about a different process, and how you machine printed metal parts is different than when you're machining billet in many cases, right? So, and I would answer it like this. I have not seen it. A lot of time, what we're talking about here is very blood, sweat, and tears that go into ascertaining that information. And that, by definition, is IP, and it's a strategic competitive advantage for companies that have invested the time and effort to really understand how to work with these materials. So I know it would be a holy grail. If it existed, it would give a lot of people a head start. It would sort of level the playing field. The people that have spent all that time and money to figure out what to do would not be happy about it. But it is an interesting question, and it's a challenge. Like I mentioned earlier, there's no machinist handbook out there for additive, not anywhere near. I mean, there's guides for design for manufacturing. But here's an interesting thing, and it was always a pet peeve of mine. You had DFM and DFAM, and it shows sort of like the mental disconnect. The people that have been in CNC and injection molding and fabrication for years, we're like, it's still manufacturing. Just get rid of the A. Now, I know there are nuances when you're designing for additive manufacturing, but they didn't specialize designing for injection molding manufacturing, design for fabrication manufacturing. And I think that it shows that this is so new. There's so many different aspects to the technology that people are trying to figure out. It's maybe 50% science, 50% art. CNC machining is like 99.9% science. It's been figured out. The costs have been wrung out. And from a hybrid standpoint, just want to throw this comment in real quick, is that we still have mills and lathes and wire EDMs in CNC. Every CNC machine has not morphed into one CNC. There are multitasking machines that do milling and turning, but they're expensive. And so depending upon the use case, I think we're going to see some companies, like I mentioned earlier, DMG Mooring and Mazak, delivering very high-end hybrid pieces of equipment to focus on very specific use cases where there's very high-value parts. But when it comes to regular parts, and parts like Aaron again was mentioning, production parts, it's about getting the cost down, producing more parts per cycle. That's where HPMJF really shines. And It's about doing that at a cost, both for the equipment and for the part, that make it an attractive alternative to CNC machining and injection molding. So I think I'll leave it at that.
Thank you very much. That's a good point, because we have just hit the 1 hour mark that is allotted to us, and we managed to do that without taking 24 hours of the audience time. So that's I'd like to thank our sponsors, Velo 3D, HP, and Desktop Metal for making this live discussion possible. I want to thank our audience, you particularly, for spending your precious afternoon with us. And I'd like to thank our event producer, Steve Paul, for making sure everything runs smoothly behind the scene. Until the next episode of Hot Seat, I'm Kenneth Wong for DE, and we are signing off. Bye-bye.